If left hand limit is equal to right hand limit is equal to functional value, then the function f of x is said to be continuous at x is equal to a. When x is greater than 1, f of x is equal to x plus 2, limit extends to a plus 0 of f of x is the definition for right hand limit. When x is greater than 5, f of x is equal to 3x minus 5. You are going to get right hand limit. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In the last class, we have discussed regarding the definition of limits, properties of limits, and the definition of continuous function and few problems based on this. Now in this session, I am going to take few more problems based on the continuity of a function. And these type of problems are very, very important. Usually you will get 1 4-mark question from this. So you will get 1 4 marks question, that is from part B. Part E. In part E, the question is from B. So suppose either it may be question number 49B or 50B for 4 marks. This is a definite question. You definitely will get 1 4-mark question from today's concept. Now, so just let us have a glance. A function f of x is said to be continuous function at x is equal to a if limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a functional value. That means if left hand limit is equal to right hand limit is equal to functional value, then the function f of x is said to be continuous at x is equal to a. That is, if limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a, the functional value, that is left hand limit is equal to right hand limit is equal to functional value, then the function f of x is said to be a continuous function. Suppose if left hand limit is equal to right hand limit, then this can also be written as limit extends to a of f of x. If this is equal to functional value, then f of x, in few problems we are going to take this limit extends to a of f of x is equal to f of a while solving the problems. Okay. Now let us consider the first problem. Let us come to the first problem. Now a function, show that the function f of x is equal to x plus 1 if x is greater than or equal to 1, x square plus 1 if x is less than 1 is continuous at x is equal to 1. What is to verify? To prove that this function is continuous at x is equal to 1. Actually, find out the left hand limit, right hand limit and functional value. Let me see first. When x is less than 1, when x is less than 1, what is defined? F of x is given by x square plus 1. Okay, less than means you will get left hand limit, limit extends to a minus f of x. So this is equal to limit extends to, what is a here? Here a is equal to 1 minus f of x. Functional value f of x is x square plus 1. Now put x is equal to 1. Then this becomes 1 square plus 1. 1 plus 1 is equal to 2. Left hand limit of this function is 2. Now let us come to the next. When x is greater than 1, what is given? F of x is equal to, f of x is defined by x plus 1. So right hand limit. The definition of right hand limit is limit extends to a plus f of x. Now this is equal to limit extends to, what is a? A is again 1 plus f of x. F of x is x plus 1. Put x is equal to 1. You will get 1 plus 1 is equal to 2. The right hand limit is also equal to 2. Now let us come to the functional value. When x is equal to 1, when x is equal to 1, f of x is defined by x plus 2. F of x is equal to x plus 1. Sorry, x plus 1. Now, f of 1, 1 plus 1, that is equal to 2. So, what do you say? Left hand limit is 2, right hand limit is 2, functional value is also 2. Left hand limit is equal to right hand limit is equal to functional value. That is, what is here? 1. Left hand limit is 2, right hand limit is 2, and the functional value is also 2, that is f of 1 is also equal to 2. Therefore, f of x is said to be a continuous function. F of x is continuous at x is equal to 1. Now, what is the geometrical meaning? So, if I draw a graph curve, this function which is y is equal to f of x is the continuous function. So, here left hand limit, right hand limit, all the functional value for this function is if it is continuous or equal. So, listen. When x is less than 1, f of x is equal to x square plus 1, limit extends to 1 minus f of x is x square plus 1, put x is equal to 1, 1 square is 1 plus 1, 2. When x is greater than 1, f of x is equal to x plus 2, limit extends to a plus 0 of f of x is the definition for right hand limit. Limit extends to 1 plus of x plus 1, put x is equal to 1, 1 plus 1 is equal to 2, right hand limit also equal to 2. When x is equal to 1, f of x is equal to x plus 1. Therefore, f of 1 is equal to 1 plus 1 is 2. So, left hand limit is equal to right hand limit is equal to functional value 2 is equal to 2 is equal to 2. Therefore, f of x is continuous at x is equal to 1. Followed. Very important problem. Now, let us come to the next problem. Now, what is given? This is very important type problem. These are all very important problems for the point of examination. There are 4-5 questions like this. Definitely, you will get one question from this part. Now, find the value of k. What is required to find is k, so that the function f is continuous at x is equal to 5. So, listen, here already defined it is continuous, they have given. So, it is continuous at x is equal to 5. That means, what is given? Given that left hand limit is equal to right hand limit is equal to functional value. Right? The function is continuous at x is equal to 5 means left hand limit exists, right hand limit exists, and they are equal to the functional value. Now, let us find out the left hand limit of this. Now, when x is less than y, f of x is less than 5, f of x is equal to kx plus 1. So, the left hand limit for this function is limit extends to 5 of f of x kx plus 1. Put x is equal to 5, then this becomes 5k plus 1. Next, when x is greater than 5. When x is greater than 5, f of x is defined by 3x plus 5. F of x is equal to 3x minus 5. So, therefore, the right hand limit is equal to limit extends to 5 of 3x minus 5. So, this is equal to, put x is equal to 5. 5 3s are 15 minus 5 is equal to 10. Right hand limit is equal to 10. Again, the functional value, when x is equal to 5, f of x is defined by, when x is equal to 5, f of x is defined by, f of x is equal to kx plus 1, kx plus 1. Therefore, f of 5 is equal to 5k plus 1. Right. Okay, listen. When x is less than 1, f of x is equal to kx plus 1. The left hand limit we are going to get is limit extends to 5 of kx plus 1 is put x is equal to 5k plus 1. When x is greater than 5, f of x is equal to 3x minus 5. You are going to get right hand limit. Limit extends to 5 of 3x minus 5. Put x is equal to 5. 5 3s are 15 minus 5 is 10. When x is equal to 5, the functional value f of x is equal to kx plus 1. So, f of 5 is equal to, put x is equal to 5k plus 1. Since it is given, since f of x is continuous at x is equal to 5, since f of x is continuous at x is equal to 5, therefore, left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? Left hand limit LHL is equal to 5k plus 1 is equal to right hand limit is 10. Functional value is equal to 5k plus 1. Let us equate first and second or second and last. So, if I equate this, 5k plus 1 is equal to 10, 5k is equal to 10 minus 1, 5k is equal to 9, k is equal to 9 by 5. So, therefore, k is equal to 9 by 5 is the required value. So, at k is equal to 9 by 5, the function is continuous at x is equal to 5. Okay. This is very important and easiest problem. See, left hand limit is equal to right hand limit is equal to functional value. Put left hand limit, what is left hand limit? 5k plus 1, right hand limit 10, functional value is 5k plus 1. Equate this first and second or second and last. 5k plus 1 is equal to 10, 5k is equal to 10 minus 1 is 9, k is equal to 9 by 5 is the required value. Followed? Very easy and important problem. Now, let us come to the next problem. Same type problem. This is also a very important problem. What is this? Find the value of k if f of x is equal to, this is the function, is continuous at x is equal to pi. Is continuous at x is equal to pi. Now, what is given? When x is less than pi, f of x is kx plus 1. When x is equal to pi, f of x is kx plus 1. When x is greater than pi, f of x is cos x. Now, let us write down the left hand limit, right hand limit and the functional value. When x is less than pi, f of x is equal to kx plus 1. So, when less than means you will get left hand limit. Limit extends to, what is the value of a? A is equal to pi here. When extends to pi of f of x is nothing but kx plus 1. So, this is equal to, put x is equal to pi. So, k into pi plus 1. Right. When x is greater than pi, you are going to get the right hand limit. The functional value f of x is defined by cos x. Now, therefore, the right hand limit RHL is equal to limit extends to pi of f of x is cos x. So, what is this cos pi? Cos pi is equal to minus 1. Since x is equal to put pi cos pi is equal to minus 1. Again further, third point, when x is equal to pi, f of x is equal to kx plus 1. Now put x is equal to pi, f of pi is equal to k into pi plus 1. Okay, so listen to me. When x is less than pi, f of x is equal to kx plus 1. F of x is equal to kx plus 1. The left hand limit extends to pi of kx plus 1. Put x is equal to pi. So, this is equal to k pi plus 1. When x is greater than 1, f of x is equal to cos x. F of x is cos x. Right hand limit is limit extends to pi of f of x is cos x, that is cos pi, since cos pi is equal to minus 1. When x is equal to pi, f of x is equal to kx plus 1. Put x is equal to pi, f of pi is equal to k into pi plus 1. Since f of x is continuous at x is equal to pi. Since f of x is continuous at x is equal to pi, therefore left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? Left hand limit is k into pi plus 1. Right hand limit is equal to minus 1 is equal to functional value k into pi plus 1. Equate first and second. So therefore k into pi plus 1 is equal to minus 1. K into pi is equal to minus 1. Transfer plus 1 becomes minus 1. Minus 1 is minus 2. Therefore, the value of k is equal to minus 2 divided by pi. That's it. This is very, very important problem. See here. Since f of x is continuous at x is equal to pi, therefore left hand limit is equal to right hand limit is equal to functional value. So left hand limit k pi plus 1 is equal to right hand limit minus 1. Functional value is also equal to k into pi plus 1. So equate this first and second. K into pi plus 1 is equal to minus 1, or k pi is equal to minus 1 is minus 2. K is equal to minus 2 by pi is the simplified answer. So therefore the value of k is minus 2 by pi. Okay. So in this type of problems, see they have given already it is continuous. Just put LHL is equal to RHL is equal to functional value. Equate it. You will get the answer. That's it. Now come to the next problem. Same type. Find the value of k if f of x is equal to kx square, if x is less than or equal to 2, and 3 if x is greater than 2 is continuous at x is equal to 2. Again this is given to be continuous. So it is given the function is continuous means straight away you can put left hand limit is equal to right hand limit is equal to functional value. Now let me check. Yes, when x is less than 2, f of x. What is f of x? K into x square. When less than 2 means you will get the left hand limit. Limit extends to the value of a here is 2. Extends to 2 of f of x. What is f of x? Kx square. Put x is equal to 2. Then this is k into 2 square. This is equal to 4k. Next, when x is greater than 2. When x is greater than 2, what is given? F of x is equal to, f of x is equal to 3. So therefore, the right hand limit is equal to limit x tends to 2 of f of x is equal to 3. This is 3. Now when x is equal to 2, when x is equal to 2, what is given? The functional value f of x is equal to kx square. So what is f of 2? F of 2 is equal to k into 2 square. So this is equal to 4 times k. Right. Since it is given, what is given? Given that f of x is continuous, since f of x is continuous at x is equal to 2, therefore, what do you write? Left hand limit is equal to right hand limit is equal to functional value f of 2. Now what is left hand limit? Left hand limit is 4k, right hand limit is equal to 3, and the functional value is also equal to 4k. Equate this, 4k is equal to 3, therefore k is equal to 3 by 4 is the required value. So therefore the value of k is equal to 3 by 4. When x is less than 2, f of x is kx square. When x is greater than 2, f of x is 3. When x is equal to 2, f of x is equal to again kx square. So less than 2 means you will get left hand limit. Left hand limit k into 2 square is 4k. Greater than 2 means you will get right hand limit. Already it is given. Function f of x is equal to 3. And the functional value, when x is equal to 2, f of x is equal to k square means put x is equal to 2, 2 square is 4, so f of 2 is 4k. Since it is given f of x is continuous, therefore for LHL is equal to RHL is equal to functional value, 4k is equal to 3 is equal to 4k, equate first and second, 4k is equal to 3, then k is equal to 3 by 4, which is the required answer. Okay, hope you are following. Now practice these problems are very important. So usually you will get this type of problems only for 4 marks. Come to this problem. This is very important problem for 4 marks. What is given? Find the value of k if f of x is equal to k into cos x divided by pi minus 2x. If x is not equal to pi by 2 and f of x is equal to 3, if x is equal to pi by 2 is continuous at x is equal to pi by 2. So this is already continuous. Further, here x is not equal to pi by 2 in the sense x is less than pi by 2 or greater than pi by 2. Both left hand limit and right hand limit are same. Now what is given here? Since x is not equal to pi by 2 means x is less than pi by 2 or x is greater than pi by 2. So therefore limit extends to a of f of x can be written as limit extends to, what is a? A is equal to pi by 2 here. Limit extends to a is pi by 2 of f of x. F of x is k into cos x divided by pi minus 2x. Now let us simplify this first. So this is equal to limit extends to pi by 2 of, suppose if I put x is equal to pi by 2, what happens in the denominator? So pi minus 2x. So if in the numerator k into sin 91 cos 90 is 0, you will get in the numerator 0. In the denominator also if I put x is equal to pi by 2, then what happens? Pi minus 2 into pi by 2, this gets cancelled. Again in the numerator and denominator 0, you will get 0 by 0, which is an indeterminate form. So therefore, let us convert this. Cos x can also be written as sin 90 minus x. Right. What is sin 90 minus theta? Cos theta. So make use of this formula. Cos theta is also equal to sin 90 minus theta. Sin 90 minus theta is cos theta. So sin cos x can also be written as sin 90 pi by 2 minus x divided by, can remove 2 common factor out. So this can be written as 2 into pi by 2 minus x. Okay. If you multiply, see, 2 into pi by 2, 2 gets cancelled, pi minus 2 into x is 2x. Now you can remove pi k by 2 common factor out from this, k by 2 out, and what is remaining is limit extends to pi by 2 of, this is sine pi by 2 minus x divided by pi by 2 minus x. So if you observe carefully, this is of the form sine theta by theta. You can take the substitution, put pi by 2 minus x is equal to theta, then what happens? Whenever substitutions are taken, the value of limit also changes. This will changes to x tends to pi by 2 converts to theta tends to 0. Then this is of the form sine theta by theta. So limit extends to pi by 2 of sine pi by 2 minus x divided by pi by 2 minus x can also be written as 1. So 1 into k by 2 is k by 2. So therefore the value of this is equal to k by 2. Otherwise, if you want, I can do the simplified step. This can be solved by taking the substitution. Let us take this as theta. Yes, put pi by 2 minus x is equal to theta. So what happens? This becomes this k by 2 as it is. Again, limit. So whenever substitutions are taken, the value of limit also changes. You know that. So when x is equal to pi by 2, when x is equal to pi by 2, what happens to theta? Theta is equal to pi by 2 minus pi by 2. This reduces to 0. So limit extends to pi by 2 becomes theta tends to 0. Theta tends to 0 of sine. What is pi by 2 minus x? Theta divided by pi by 2 minus x is theta. So this is equal to k by 2 into, you know, this is the standard formula theorem, limits theta tends to 0 of sine theta by theta is also equal to 1. So this is equal to 1 into k by 2 is k by 2. So the value of limit of this function is k by 2. Listen to me, this is very important problem. When x is not equal to pi by 2, in the sense x is less than pi by 2 or greater than pi by 2, so therefore both left hand limit as well as right hand limit are same. Limit extends to a of f of x is equal to limit extends to pi by 2 of, what is f of x? K cos x divided by pi minus 2x. Now this k into cos theta can also be written as sin 90 minus theta. Convert cos to sin. Cos x can be written as sin 90 pi by 2 minus x divided by, you can remove 2 out. So this is 2 into pi by 2 minus x. K by 2 out. So if you multiply by 2, 2 gets cancelled, pi minus 2x, you will get the same step in the numerator in the previous steps. Now k by 2 out, this can be written as k by 2 into, what is left over in the numerator is sin pi by 2 minus x divided by pi by 2 minus x. Now let us take the substitution, put pi by 2 minus x is equal to theta, and whenever substitutions are taken, the value of limit also changes. When x is equal to pi by 2, theta is equal to pi by 2 minus pi by 2 is 0. X tends to pi by 2 becomes theta tends to 0. K by 2 into theta tends to 0 of sin pi by 2 minus x is theta divided by theta. Sin theta by theta is equal to 1. So k by 2 into 1 is equal to k by 2. Followed? Now, since it is given, what is given? F of x is continuous. Okay? Let me rub. I will rub this and go to the next page. This is the limit. Now, therefore, since f of x is continuous, since f of x is continuous at x is equal to pi by 2, therefore, limit extends to a of f of x is equal to f of a. Now, limit extends to f of x is nothing but k by 2 is equal to, what is the functional value? Functional value. So here f of a is nothing but f of pi by 2. F of pi by 2 is equal to 3. When x is equal to 3, f of x is equal to pi by 2. That is, when x is equal to pi by 2, f of x is equal to 3. Therefore, f of pi by 2 is equal to 3. So k by 2 is equal to 3. Cross multiply this. K is equal to 3 into 2 means, therefore, k is equal to 6. 6 is the required answer. So therefore, the value of k is equal to 6. This is very important problem. See, Since f of x is continuous at x is equal to pi by 2, therefore limit extends to of f of x is equal to f of a. When x is equal to pi by 2, functional value f of x is given to be 3. So therefore f of pi by 2 is equal to 3. K by 2 is equal to 3 means k is equal to 2 into 3 is k is equal to 6. So therefore the value of k is equal to 6 in this case. Now let us come to the next problem. This is also very important problem. What is the problem? Find the relationship between a and b so that the function is defined by f of x is equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3 is continuous at x is equal to 3. Now this is given. Okay, I'll straight away go to the definition. Since f of x is continuous at x is equal to 3, therefore limit x tends to 3 minus f of x is equal to limit x tends to 3 plus f of x is equal to functional value f of 3. Okay, this is limit x tends to 3 minus what is f of x? When x is less than 3, f of x is ax plus 1 is equal to limit x tends to 3 of when f of x greater value is when x is greater than 3 f of x is bx plus 3. This is equal to functional value f of a is equal to ax plus 1 at x is equal to what is the value of x? 3. Now substitute here. So if you put x is equal to 3, then you will get 3a plus 1 is equal to, put x is equal to 3, you will get 3b plus 3 is equal to, again put x is equal to 3, 3a plus 1. So 3a plus 1 is equal to 3b plus 1 is equal to 3a plus 1. What is to find here? To find the relation, only the relation, not solving. Don't solve, just find the relation between a and b. Now consider 3a plus 1 is equal to 3b plus 3. Now 3a plus 1 is equal to 3b plus 3. So just keep this 3a is equal to 3b plus 3. Transfer plus 1 becomes minus 1. 3a is equal to 3b plus 2. Now divide by 3, you will get a is equal to 3 gets cancelled, b plus 2 by 3. This is the relation. So if you want a is equal to b plus 2 by 3 is the relation. Okay, see here. Since it is a continuous function, limit x tends to 3 minus f of x, left hand limit is equal to right hand limit, limit x tends to 3 plus of f of x is equal to functional value f of a. So that is limit x tends to 3 minus ax plus 1, limit x tends to 3 plus bx plus 3 is equal to ax plus 1 at x is equal to 3. So put x is equal to 3, 3a plus 1 is equal to 3b plus 3 is equal to 3a plus 1, equate first and second. 3a plus 1 is equal to 3b plus 3, 3a is equal to 3b plus 3 minus 1, 3a is equal to 3b plus 2, or divide by 3 you will get a is equal to b plus 2 by 3. Suppose if you want, or you can also solve like this, or equate this 3a plus 1 is equal to 3b plus 3. If you want b, transfer this 3a plus 1 minus 3 is equal to 3b. Okay, what is this? 3a, 1 minus 3 is minus 2 is equal to 3b. Divide by 3, you will get a minus 2 by 3 is equal to b. So a is equal to b plus 2 by 3, or if you want you can transfer this you will get a minus 2 by 3 is equal to b, or a is equal to b plus 2 by 3. This is the relation between a and b. Very important problem. Okay, now let's come to the next problem. Now this is also a very important problem for 3 marks. Find the values of a and b such that the function f is defined by f of x is equal to 5 if x is less than 2 and 21 if x is greater than 10, and ax plus b if x is in between 2 and 10. So there are two values, is continuous function. So first at x is equal to 2 find out the limits, again at x is equal to 10 find out the limits. When x is equal to 2, let us come to the first case. When x is less than 2. So this is at x is equal to 2. At x is equal to 2, when x is less than 2, what is f of x? The functional value is 5. You will get the left hand limit. Left hand limit is equal to limit x tends to 2 minus f of x, that is equal to 5. When x is greater than 2, when x is greater than 2 means you will get f of x. See, here the value of x is in between 2 to 10 means if this is greater than 10, therefore f of x is equal to ax plus b. So greater than means automatically by definition you will get the right hand limit. Right hand limit extends to a minus, here instead of a it is 2, extends to 2 of f of x is equal to ax plus b. Substitute the value, put x is equal to 2, you will get 2a plus b. Again functional value, when x is equal to 2. See, first case x is less than 2, second case if x is greater than 2, and the third case when x is equal to 2. When x is equal to 2 means f of x is equal to defined by f of 2 as 5. So f of 2 is equal to 5. Okay. Now therefore, since f of x is continuous at x is equal to 2, since f of x is continuous at x is equal to 2, therefore left hand limit is equal to right hand limit is equal to functional value. Let me substitute left hand limit is equal to 5 and right hand limit, what is the right hand limit? 2a plus b is equal to, again functional value is 5. So therefore 2a plus b is equal to 5. Let us represent this as equation number 1. Followed. So see here, when x is less than 2, f of x is 5, therefore you will get the left hand limit. When x is in between 2 to 10, x is greater than 2, f of x is equal to ax plus b, therefore the right hand limit is limit extends to 2 of ax plus b, put x is equal to 2, 2a plus b. When x is greater than 2 means you will get this, that is again x is less than 2. When x is less than 2 means f of x is equal to 5. So therefore the functional value f of 2 is equal to 5. Therefore left hand limit is equal to right hand limit is equal to functional value. At x is equal to 2, you will get 2a plus b is equal to 5 as equation number 1. Followed. So this is equation number 1, 2a plus b. Equation number 1. Now let us come to the second part. I will rub this. Now similarly at x is equal to 10, at x is equal to 10. Listen, when x is less than 10, when x is less than 10 means f of x is equal to ax plus b. Straight away you will get the left hand limit. Left hand limit is equal to limit x tends to a. What is a? It is 10 of f of x is ax plus b. So put x is equal to 10, you will get 10a plus b. Similarly, when x is greater than 10, so you will get f of x. What is f of x here? When x is greater than 10, f of x is equal to 21. The right hand limit is limit x tends to 10 of f of x is equal to 21. Again, when x is equal to 10, x is equal to 10, f of x is equal to 10, that is f of 10 is equal to 10. So right hand limit is equal to 21 and the functional value when x is equal to 10, f of x is defined to be 21. F of x is equal to 21. So since it is continuous, so therefore since f of x is also continuous, at x is equal to 10, therefore what is left hand limit is equal to right hand limit is equal to functional value. Left hand limit, what is left hand limit? 10a plus b is equal to right hand limit is equal to 21 and functional value is also equal to 21. So therefore you can write 10a plus b is equal to 21. This is equation number 2. Okay, see, when less than 10, f of x is ax plus b, therefore put x is equal to 10, 10a plus b, and remaining 2 are right hand limit and the functional value are 21. Since f of x is continuous, therefore 10a plus b is equal to 21, that is equal to 21 means 10a plus b is equal to 21. Now solving equations number 1 and 2. Let us solve 1 and 2. Now solving 1 and 2. Solving 1 and 2. What is equation number 1? 2a plus b is equal to 5. And equation number 2 is 10a plus b is equal to 21. Subtract this. Minus, minus, minus. Plus b minus b gets cancelled. 2 minus 10 is minus 8a is equal to 5 minus 21 is minus 16. Therefore, a is equal to minus 16 by minus 8 is 2. So, a is equal to 2. Substitute this value in any one of these equation. From 1, what is b? b is equal to 5 minus 2a. So, this is 5 minus 2 into a is 2. This is 5 minus 4 is equal to 1. b is equal to 1. So, therefore, for this function, a is equal to 2 and b is equal to 1. These are the values. Very important. So, a is equal to 2 and b is equal to 1 are the values of a and b. So, a is equal to 2 and b is equal to 1. These are the two values. Now, come to this problem. The next problem. For what value of lambda, the function f of x is equal to lambda into x square minus 2x if x is less than or equal to 0 and 4x plus 1 if x is greater than 1 is continuous at x is equal to 0. For what value of lambda? Same, you have to find out the value of lambda. For what value of lambda, the function is continuous at x is equal to 0. Now, let us find out the value of x is 0. When at x is equal to 0, here given a is equal to 0, that is x is equal to 0. Now, write down the left hand limit. When x is less than 0, what is given? F of x is equal to lambda times x square minus 2x. Write down the left hand limit. Left hand limit is limit x tends to 0 minus f of x. This is limit x tends to 0 minus lambda times x square minus 2x. What you will get? Since x is equal to 0 minus 2 into 0, 0 minus 0, lambda into 0, you will get 0. When x is greater than 0, what is f of x? When x is greater than 0, f of x is equal to 4x plus 1. You will get the right hand limit. Right hand limit is limit x tends to 0 plus f of x. This is limit x tends to 0 plus, what is f of x? 4x plus 1. Put x is equal to 0. 4 into 0 is 0 plus 1 is equal to 1. When x is equal to 1, when x is equal to 0, f of x, the functional value, f of x is equal to 0, f of x is equal to again lambda into x square minus 2x. So, if you put x is equal to 0, f of 0 you will get lambda into 0 is equal to 0. So for what value of lambda the function is continuous given, since f of x is continuous at x is equal to 0, therefore left hand limit is equal to right hand limit is equal to functional value. It is given since f of x is continuous at x is equal to 0, therefore left hand limit, right hand limit, functional value are equal. What is left hand limit? Left hand limit is 0. What is right hand limit? Right hand limit is equal to 1 and f of x is also, this is 0. Left hand limit and right hand limit, they are not equal. So for none of the value, for no value of lambda, it is continuous. 0 is equal to 1. This is not possible. This is not possible. So 0 is not equal to 1. This is not possible. So, for no value of lambda, this is continuous at x is equal to 0. Okay. Now, let us come to the next problem. Discuss the continuity of the function. So, mod x divided by x, signum function. Discuss the continuity of the signum function f of x is equal to mod x divided by x, where x is not equal to 0 and 0 when x is equal to 0. Now, here you know this, since f of x is equal to modulus of x by x means, So this modulus of x is nothing but plus or minus x divided by x. When x is equal to positive value, when x is greater than 1, f of x is equal to plus 1. When x is less than 1, f of x is equal to minus 1. When x is equal to 0, f of x is equal to 0. You will get, right? So therefore this f of x can be written as f of x is equal to, this is f of x is 1 when x is greater than 0. Again this f of x is equal to minus 1 when x is less than 0, 0 when x is equal to 0. 1, minus 1 and 0 are the values. When x is greater than 1, f of x is 1. X is less than 1, f of x is equal to minus 1. When x is equal to 0, f of x is equal to 0. Therefore, f of x is equal to 1, minus 1 and 0. Now, by taking this, check whether it is continuous or not. So, therefore, f of x is equal to 1 when x is greater than 0, f of x is equal to minus 1 when x is less than 0, f of x is equal to 0 when x is equal to 0. By looking through this, you can say whether it is continuous or not. See, right hand limit is 1, left hand limit is minus 1 and the functional value are 0. 3 different values you are going to get. Therefore, this is not continuous, this is discontinuous function. Let us verify this. Let me verify. Left hand limit. Left hand limit. What is left hand limit? Limit extends to 0 minus f of x. So, when x is less than 0, f of x is equal to minus 1. Right hand limit. Right hand limit is limit extends to 0 plus f of x. When x is greater than 0, f of x is equal to plus 1. And the functional value, f of x is equal to, f of 0 is equal to 0. So, here left hand limit is equal to, right hand limit is equal to the functional value. What is left hand limit? Minus 1. Right hand limit plus 1. And the functional value 0. They are not equal. So, therefore, f of x is not continuous. F of x is not continuous at x is equal to 0. So, this is not continuous at x is equal to 0. Okay. Now, let us come to the next problem, the last problem. Find the value of a and b, same type which we have solved in the previous problem, such that f is defined by ax plus b, a plus bx if x is less than 1, 4 if x is equal to 1, and b minus ax if x is greater than 1 is continuous at x is equal to 1. See, given at x is equal to 1, it is continuous. F of x is continuous. So, therefore, left hand limit is equal to right hand limit is equal to functional value. Okay, what is left hand limit? Limit extends to 1. Since it is continuous at 1, f of 1 minus less than means a plus bx is equal to limit extends to 1 plus f of x when x is greater than 1 is b minus ax is equal to the functional value f of x at x is equal to 1 is 4. Apply the limit for this. A plus b is equal to b minus a is equal to 4. Now, what you say? A plus b is equal to 4 and b minus a is also equal to 4. Equate these two. A plus b is equal to 4. First and last, second and last. Again, b minus a is also equal to 4. Now, simplify this. If you add minus a plus a gets cancelled, b plus b, 2b is equal to 8, b is equal to 8 by 2 is 4, b is equal to 4. Now, take any one of these two equations. Since a plus b is equal to 4 means definitely another value is 0. So, from this, from a plus b is equal to 4, a is equal to 4 minus b, 4 minus b is 4, 0, a is equal to 0. So, therefore, the values of a is equal to 0 and b is equal to 4. These are the two values of a and b. Followed? See, at x is less than 1, at x is equal to 1, f of x is continuous given. So, therefore, left hand limit, right hand limit, functional value at x is equal to 1 are same. So limit x tends to 1 minus left hand limit ax plus b, right hand limit b minus ax, the functional value is 4. So a plus b is equal to b minus a is equal to 4, a plus b is equal to 4, b minus a is equal to 4, minus a plus a gets cancelled, solving equations 1 and 2. 2b is equal to 8, b is equal to 8 by 2 is 4, b is equal to 4, substitute here, a plus b is equal to 4 or a is equal to 4 minus b, 4 minus 4 is 0, therefore a is equal to 0. So the values of a and b are a is equal to 0 and b is equal to 4. So this is also an important problem. So hope you followed this. This is very important session, and these type of problems are very important. Definitely you will get one question from this section for 4 months. Definitely you will get one question from these problems. Only these problems will repeat. If you practice these problems, definitely you will score 4 marks in the final examination. So that's all for the day. Thank you very much.